Hi, I'm here to talk about units. Now, units are really fundamental to what we're going to do in this course, and you really need to understand them. So, one thing I want to suggest is that you pause the video here and just take a minute to look at these, maybe write them down into your notes, because you're going to want to look back at these at some point in the future. Now, I said units are fundamental to what we do, and that's because, let's say you take a measurement and you say something is 6 long. That doesn't make any sense. You need to have a unit associated with it. And there's several units that we use regularly in this course. Now, there are a lot of other units that are used to measure distance and displacement, for example. Some of these terms you might not be familiar with. That's okay at this point. I will explain them as the course goes on. But if you want to measure the distance to something, you can use meters, but you can also use centimeters, or inches, or feet, or miles, or kilometers. So there are a lot of different units that we use, but we try to stick with a standard set, more or less, in this course. These are often called or related to the System International, SI units. And some of these are directly related to SI, and some of them are what we call derived units, meaning they can be created with SI units. So force and weight are measured in newtons, and that is a derived unit that can be expressed with some of the other units, like kilograms, meters, and seconds. I'm going to go through these, and in some cases I've written down what they represent. Time, for example, is in seconds. Sometimes you'll see it expressed in meters. Sometimes you'll see it expressed in minutes or hours, and you might want to convert to seconds. If you see distance in centimeters, you might want to convert to meters. Mass is expressed in kilograms. Now, this is different than weight, which goes by a little letter f sub g. Almost all of these have variables associated with them. I didn't write them in, but mass, as you might expect, goes by the letter m. Time goes by the letter t, for example. And these represent the variables we use. Those variables are different than the units. Speed and velocity. Velocity goes by the letter v, is expressed in meters per second. Now, force, which goes by the letter F, and weight, which goes by the letter F with a little g, so I'll call that F sub g, are expressed in newtons N. Now, this is different than kilograms because weight is a force, and the g stands for gravity. That's the force of gravity. Some things like energy and work. Work goes by the letter W, and this is going to come back to confuse you even more in the future. They are both measured in units of joules, J. Now, you'll also see work down, the letter W down here for watts, because power is measured in watts. Don't get confused. If you're looking at a variable, that for W, that W represents work, which is related to energy. If you're looking at a unit that goes with something for W, that would be watts, that goes with power. So variables are different than units. Momentum and impulse. Momentum goes by a lowercase p, different than power, which goes by an uppercase p. Impulse goes by the letter J. They both have the same units, kilograms, meters per second. Confused yet? Sometimes, acceleration, for example, which I probably should have put up there, A goes by meters per second squared. Sometimes you'll express this as meters per second, because the speed changes, and as that speed changes, you're accelerating. You're changing a certain number of meters per second every second. That's where you get meters per second squared. Electric charge, Q, goes in coulombs, C. Electric current, I, is in amperes, A. Electric potential difference, which is sometimes called voltage, has a letter V associated with it. That's where you get V from voltage, and it's measured in volts, V. Electrical resistance, R, is in ohms. Now, ohm is a person's name, but the symbol for it when we use units is a little omega symbol. And sometimes we'll have unitless quantities that have no units associated with them at all, and they're often ratios of different things, like the index of refraction is a ratio of the speed of light in a vacuum to the speed of light in a material. Letter N has no unit. Coefficient of friction has no unit. It goes by a Greek letter called mu. If you ever have questions on this, please feel free to ask, but it's going to be important that by the end of the course you understand most or all of these. Thank you very much. This is the end of the video.